Okay, so yesterday, so we have discussed already about our lesson yesterday. It's all about sets. Okay, so turn your book on page 194. So we are on lesson 3.5 now. So it's all about sets. So again, so when we talk about sets, so what do you mean by sets, Nandi? What do you mean by sets?
So they're either like there can be many things categorized into like by different forms. Like there's the roster form, which has the brackets they use, and then you categorize it. And if it's in like letter form, it can't have two of the same letter.
Okay, so when you say set, it is a collection of objects. It can be collection of numbers, things, letters that is well defined, okay, or clearly defined. So just remember, if you are talking about sets, it pertains to a group. Okay? Yes. One,
Do I need to write this down?
you have your book. Okay? Or you can just write.
We
Okay?
don't need to write it?
You can write.
I don't have paper right now.
Okay. So when we say set, so this is a collection of objects that is clearly defined. Okay, yesterday, so we have discussed about the ways on how we are going to describe a set. Okay, so set is named using capital letter. So when we are naming sets, so we are using capital letters. For example, we have here set A is equal to, so aside from the capital letters, so we also have the braces, right? Okay, so we have, for example, we have here set A consists of elements such as 1, 2, 3, 4, 5. Okay, it is enclosed by a braces, and inside the set, this is what we call the element or the elements. The elements are the things that you can see inside the set. Things or numbers or letters or anything that you can see inside the set. And we have the symbol for element. So what's the symbol for element?
It's like an E.
E,
except-
right? It's E,
Like an out certain words E.
this one. So we can say that the element 2 is an element of set A. The name of our set is set A. Okay? So aside from elements, so we also have here the cardinality of set. Cardinality of set. And what do you mean by cardinality of set? Ashley, when we talk about cardinality of a set, so we are talking about what? For example, you have set A. What's the cardinality of set A? We have 5. Okay, when you say cardinality, it is the total number of elements that we have. Total number of elements inside the set. Okay, so you just count how many elements do we have, and that would be our cardinality of set. Okay, and every elements in a set, it is being separated by a comma, and it is only written once. Once. Okay, we have two ways to describe or to write set. The first one, what's the first one, Nandi?
Roster form.
Okay, we have the roster form, or sometimes it is called
Set builder notation.
listing method.
Oh, sorry. That's the second one, right?
Yeah. And the second one is the set builder notation. Okay, so let's create an example of set, or let us describe a set using these two methods. Okay, for example, we have set A. Set A consists of elements that are divisible by 2 less than 10. What do you think are the possible elements? Yes. Divisible by 2 less than 10. We have divisible by 2.
So 3.
Hmm?
Oh, divisible by 2.
Yeah, divisible by 2 less
And
than
then
10.
less than 10. Okay, 2,
We have 2,
4,
4,
6,
6,
8.
8.
That's it.
That's it, because less than 10. So this is an example of a set using roster method or listing method. We just list down the elements using braces. This is by roster method. If we are going to represent or describe this set using set builder notation, so we're just go, yes,
The set A or is
okay, set A, so the name of our set A, we have slash, such that A, and what can you say about the elements?
is divisible by 2.
It's a set of numbers, right?
Yes, a set of number divisible by 2 and
Divisible by 2
less than 10.
less than 10.
Yes.
That's the rule. So always remember, when we are talking about set builder notation, so we are describing the set using the rule. What is the rule based on the given element? Is it clear? Okay, let's have another example. For example, we have here set. We can name set using capital letters, any letters in the English alphabet, such as A, B, C, D, E, F, and so on and so forth. Okay, for example, set B consists of integers.
Minus.
What are the possible elements here? Yes, can you write it on the board? Set B consists of integers. Okay, we use the braces because if the elements are not inside the braces, therefore that's not a set. It's not. Okay, isn't it? When we talk about integers, it includes the positive and negative numbers on a number line including 0. Okay, very good. So we have here 3 dots here on the left side, since negative numbers goes on
The left side.
left side infinitely, right? And this one we have 0, 1, 2. We also have here 3 dots.
Yeah.
3 dots means it's
It's
infinite,
keep going, yeah.
right? And this is what we call the ellipsis. Okay, so if we're going to write this one using set builder notation, so we can just write this one as B, such that B is a set of integers. Okay, we have 2 kinds of set. We have 2 kinds of set. The first one is the finite set, and the second one is the infinite set. So what's the difference between the two?
Finite means it ends. It has an end.
Okay, exact,
Yeah.
right? We have exact number of elements. This one is infinite, so we have, okay, we don't have exact number of elements. So this is an example of finite set, wherein we have 1, 2, 3, 4, 5 elements. And this is also an example. This is an example of infinite set, wherein we don't know how many elements do we have in this particular set. Okay? Okay, how about set C? For example, set C consists of elements such that is factor of 15. Set C consists of elements that are factor of 15. So what are the possible elements, Von?
Factors of 15.
Yes.
So, can be divided by 15?
What are the factors of 15? This is the element of set C.
3, 5, 1, 15.
Okay, we have 3, comma, 5, 1, 15. Right? Factor.
Why does it have to be in that order?
Okay, that's
It can
Okay.
be in any.
okay. We have what we call the equal set, and we also have what we call the equivalent set. So when we say equal set, the elements are written. For example, equal set we have 1, 2, 3. The other element is 3, 2, 1. These two sets are just the same. So they are called equal set. The elements are just written, not in order. Okay, on the other hand, if we are talking about equivalent set, these are sets wherein, for example, 1, 2, 3, the other set is 4, 5, 6.
Why do you have to write the fancy swirly thing?
This one, so that is an indication that is a set. So if you don't have the braces, that is not a set. Okay? So as you can see, they have different elements. But how? Why do we say, or do we call this one as equivalent set?
Because
Yes.
this one starts it, and that one like it finishes it.
Mm-hmm.
I don't know how to explain it, but.
How about you, Ashley? We have here 1, 2, 3 as an element of the first set, 4, 5, 6 as the element of the second set. Why do we call this one as equivalent set? What do you think is the reason?
Because they both have I forgot. Is it because they have the way you can like put them, when you put them together, they both amount to the same thing? Is it 8 like 1 2 1 3 3 2 like that, or
Okay, as you can see, how many elements do we have?
3
How many elements do we have?
3?
3. If they have the same cardinality, therefore that is what we call equivalent set. Okay, therefore equal set is also an equivalent set, but not equivalent set. We call it equal set. So if you have the same number of elements, therefore that is equivalent set. And if we have exactly the same elements inside the sets, therefore that is an equal set. Is it clear? Okay, let's have another example. For example, here you have set M consists of letters in the word Philippines. What are the possible elements?
Should I come up to the board?
Yeah, okay. So what are the elements that you can form in the word Philippines? The letters in the word Philippines. Small letters.
Oh, yeah.
Okay, usually in writing sets, so we use small letters. Example of a set is a deck of cards. Uno cards that we have played before, right? So we have Uno cards. That's a group of cards. Okay, is it? Let's check. P.
Oh, and that's.
So we have 3P. So since we have 3P here, we just write 1. 1P. So it's just written once. So H, I, L. So I is just the same. Then we have N, E-S. And you forgot something here.
Yeah, the other bracket. That's
Okay,
what I wanted.
you should close. Okay, so this would be the elements of the letters in the word Philippines. Is it clear? Okay, how about set N consists of, for example, we have months in the year that start with J. What are the elements?
January.
We have January. What's the other month that start with letter J?
June.
We have June, J, May, July, August.
That's it.
That's it? Huh?
Oh.
Okay.
Oh.
Oh. Okay, so these are the elements.
October. Oh.
October. Okay, so that's how, right? Is it clear? It's easy, right? What do you want? What do you prefer? The roster method or the set builder notation?
Well, would you give us math like in this like? I mean, can I see one so like how would it look if you gave us like a math problem? And if you give us a math problem, do we have to pick the roster method or the set builder notation
The
method?
roster. It's up to you. How are you going to describe the set? Okay, that's why we have ways on how to describe set. Okay.
I like the roster method.
Yeah, it's easy.
Yeah.
Right? Okay, so aside from sets, so we also have what we call subset. So the subset here, so when we say subset, these are the elements that are part of the set. So for example, we have set A. The elements of set A are 3 and 4. So how are we going to create subset here, Namdi?
One you put it under as 3, then another one as 4, then another one is empty.
Okay, so we have 3 and 4 as the elements. So when we are talking about subsets, the first thing that we have here, the subset of 3 and 4 is empty set. That is the first one. An element that, a set that has no element, this is what we call the empty set. Or it is also can be denoted by this symbol. And this is the symbol for null set, which means that the set has no element. Okay, so this is the first subset. The second one is 3. Third one is 4. And the fourth one is the element itself. So these are the subsets. How many subsets do we have?
3.
We have 1, 2, 3, 4 subsets. Okay? Okay, you try this one. So what are the subsets of, for example, we have summer, fall, spring, what's the other season?
October.
October?
Oh.
Summer, fall, spring, and
Winter.
okay, we have winter. Okay, can you identify the subset,
Winter.
the subset of these 4
Winter.
seasons?
Summer, fall, spring, winter, summer, winter, fall, spring, summer, fall, winter,
October.
nothing.
October.
And then nothing.
Okay, the first one is empty set,
Yep.
right?
Like these bars.
No. Okay, we don't have element. How about if we have, so we have spring, can we just write SU? So spring, summer, fall, what's the other one? Spring, then winter.
Keep careful. I still have it. Do you want it back?
Right? Okay, can you give me the other subsets here? One, we have
October.
October in that one.
So we already have one element per set.
Summer, fall.
Okay, summer, fall. We have
Spring.
fall, summer. No.
No,
Fall, spring.
yeah.
We have spring,
Spring, winter,
winter. We also have winter,
fall.
summer. Right? It would be easy if you arrange like this. Summer, fall, fall, spring, spring, winter. Then winter, summer. How about summer, spring? We don't have yet? Right? Summer, spring. And also fall, winter. Right? We also have the subset fall, winter. Are we done?
Summer, fall, spring, winter, winter, fall, spring, summer.
Autumn.
That is fall.
Okay, we are done with the two elements. How about if we have three elements here? So we have
Summer, fall.
summer, fall, spring, right?
Summer, fall.
Okay, we can also have fall, spring, winter.
Mr. Beluga,
Hmm?
do we have to write all this?
Yeah. We all have spring,
winter, summer.
winter, summer.
No.
Do we still have? 1, 2, 3. How about summer, spring,
Spring.
winter? Right? Summer,
We
spring,
have that.
winter. We already have. Fall, spring. Okay. How about summer, fall, spring, winter? Right? Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 elements. I think we still have one. Can you find that other subset that we have missed?
Then you write the same thing again.
Mm-hmm.
So
Actually,
summer, fall, spring.
if we have summer and
Oh.
winter, it's just the same as winter, summer. That is just counted as one subset.
Will we have homework on this?
Yeah. Later. Okay. Can you find the other one? Vaughn?
Is it, what category is it in?
Hmm?
It's in that.
What category is it in?
You can't see it?
Oh, it's in the small one?
Hmm.
Wait, is it, spring, summer?
Spring, summer. Do we have? We have here. We have already.
Is it winter, fall? Oh no, we already
Here.
did that.
Okay.
Is it, summer or winter? No. Is it fall, spring?
Fall, winter. Fall, spring. Okay, we already have. That's all.
Are we missing one?
No.
Are we missing
we're
one?
not. That's all.
Summer, fall, spring. Fall, spring, winter. Spring, winter, summer. Summer, spring, winter. Summer, spring, winter. Okay, just have 15. Okay, anyway, how about set C? The elements are 1, 2, 3. What are the subsets here?
1, 2.
We have empty set.
Yeah, empty set.
We have 1. We have 2.
3.
We have 3. We also have 1,
2.
1, 2. We have 2, 3.
3.
We have 1, 3. And we also have 1, 2, 3. Right? So we have 1, 2, 3, 4, 5, 6, 7, 8 elements. Okay, that is subsets. Is it clear?
Hmm. We might. We might be missing one.
No, we're not.
Yeah, we might be.
No, we're not. Then do it on your paper. Then when you see it, then you can spend all class.
Yeah.
Oh, it is.
Oh, yeah.
Summer
Mhm.
and
Can you
winter
come
and
here?
fall.
Summer,
Winter, fall.
winter, and fall,
It's right there. Oh wait.
right?
Mm.
That's why we're missing one. I told you we have 16 subsets here.
Hmm.
We have summer, winter, fall. Winter, summer, spring. Winter, fall, spring. Fall, spring, summer. So we have summer, winter, fall. Okay? Okay, so we have here, so set builder inequalities and set builder notation. So how are we going to represent the solution of the inequalities using set builder notation? So first one here, for example, we have negative 5x plus 7 less than or equal to 70. So again, how we're going to either solve for the solution here?
X is greater than or equal to -2.
Isn't it? We subtract 7 here, right? Subtract 7 both sides. So this would be negative 5x less than or equal to 10. So what's the value of x?
-2.
It would be x greater than or equal to negative 2. Right? Because we divide both sides by negative 5. Isn't it? If we divide it by negative, the inequality symbol will change. So therefore, the solution is x greater than or equal to negative 2. So by roster method, so our set would be, what would be the solutions? Using roster method. X is greater than or equal to negative 2. What are the possible solutions?
Wait, what?
What would be the solutions
Oh,
here?
-10. No, 10.
Minus 2, negative 2.
What?
The solutions. Yes. We also have negative 1, 0, 1, 2, and so on and so forth. Okay, it means that the value of x
Oh,
is
that-
greater
okay.
than or equal to
Okay,
negative
now I
2.
see.
So all the elements that is greater than or equal to negative 2, that would be the solution. Okay, using set builder notation, so we just write x such that x greater than or equal to negative 2. So this is just the answer. If you are going to represent the solution using set builder notation. Okay, easy, easy. Okay, next. So we also have what we call the universal set and complement of a set. This is the last one. Okay, when we talk about universal set, this pertains to the elements that are found on the whole group. Example, so we can represent this one using box. So for example, this is set A, and this box is represented by universal set. For example, the universal set for the month of the year. So what are the months of the year? We have January, February, March, April, May, June,
October.
July, August, September, October, November, December. So that we can consider that one as universal set. And for example, we have set A consists, okay, universal set is being represented by the capital letter U. For example, the universal sets are the months of the year.
Decks of cards.
And set A consists of months that has 31 days. So what are the elements of set A? What do you think are the
December.
elements of set A? If we had
December.
December. December has 31 days. We have
October.
October. Another
What?
another month that has 31
Why?
days.
Oh, it's Halloween.
How about August?
Well, I live on a hill.
Right? August has 31 days. Also, we have July. Right? How about January? January has also 31 days. January has 31 days. How about February?
No, 28 days.
Okay, March.
Sometimes 29, right?
March has also 31 days. How about April? Is April has 31 days? And lastly, we have May.
Me.
May. So when we are talking about the complement of set or complement of set A, so we can just denote this one as symbol A, then this is the symbol for complement. We have slash above the name of the set. Okay, so what are, when we talk about complement of a set, these are the elements. Again, complement of a set, these are the elements that you can see on the universal set but are not found on set A. So what are the months that has no 31 days? That is the complement of set A. Ashley, can you give me one? We have June. February.
February.
February. Right? April.
May.
We have May.
Oh, wait, hold on.
May has 31 days.
November.
About July, August, September, right? September has 30 days only.
November.
November. So that is this December. Okay. Last example. Set universal set we have 1, 2, 3, 4, 5.
What's my favorite?
And set B we have 2, 3, 5. So what is the complement of set B? So this is the universal set, isn't it? Set B
One.
just came from here.
4. 1 and 4.
So B complement is just 1 and 4. It means whatever element that you can see on the universal set that is not found on that set, that is the complement of the set. Right? So 1 and 4 is not found on set B. Therefore, the complement of B is just 1 and 4. Okay, for your homework, we have page 197, number 9 to 27 are numbers. Page 197.
My sister was born in March. My sister was born in March. Who? Chloe.
0, 1, 2, 3. That's it.
Okay, so that's all about sets. Do you have question?